1, 2, 3. All right, and we're live. All right, here's something completely different than anything else that we've done on this channel. We're going to fix an Xbox with a bad HDMI port. This is actually a very common repair that we see on video game consoles, and we've had so many of them come through. I just decided to just go ahead and kind of mix things up. Instead of doing MacBook Logic board repair, let's do a console HDMI port repair, just to kind of show the steps of what we do to complete this repair, kind of give guidance on how the repair is properly done as well as just kind of showing the tools that we're going to use for this repair. So I've already gone ahead and done all the boring work and had a coworker of mine disassemble the motherboard for me. And you can see right here, this one is an Xbox Series X. So the motherboard on this one, it technically comes in two parts, two motherboards that are held together with an interposer or interconnector cable. So we just need this one part that has the HDMI on it. This one, if I can actually get a good look at it under the microscope, I'll show you where it is physically damaged. Let's actually try the overhead camera. I had to set up my whole system up here a little bit differently. But you can kind of see, let's focus in on that a little bit more. That right side of the HDMI pin, it's not focusing. There we go. It has some damage to it, so it's not going to make a connection anymore. And that can happen if you're just kind of shoving in an HDMI cable directly into the HDMI port without looking. We all do it, and if it grabs the edge of that middle piece of the HDMI board, it's just going to break off. Another common thing that happens to these Xboxes, PlayStations as well, cable gets left behind, decide to transport it to a friend's family house, and you just kind of wrap it around the console. It puts a strain and kind of pries the HDMI cable or HDMI port using the cable off of the motherboard. When that happens, you'll actually have pins on the back of the port where the motherboard meets that is damaged or ripped off, or just not soldered on anymore. This one just has the internal port is physically damaged. So we're going to go ahead and repair that. Let's get everything set up here. So everything that I'm currently using, I'm using a board preheater. This is a must in my opinion. This is just going to go ahead and generate heat underneath the board so that the entire board has a nice even ambient temperature. So that way I don't have to use as much heat with my heat gun. Ooh, actually I completely forgot. I need to record this for our social media using another phone here. Okay, sorry about that. All right, so let's go ahead and turn on our preheater. This one, the brand on it, it says Puhui. I don't know how you pronounce that. P-U-H-U-I. We ended up just getting this one online. I think it was around $200, $250. If you're a repair shop, I highly recommend investing in one of these. And we're going to go ahead and set the temperature here. This one I already have preset, but we're going to put it at 200 Celsius. So that way, this whole entire motherboard of the Xbox is at a nice even temperature of 200 Celsius. If you try doing the repair without a preheater, it is possible, but it's going to require a lot more heat from your rework, your reflow station, since the main part of the motherboard is copper. It's ground. So ground also doubles as a heat sink. So as you heat up the board, the ground is then going to pull the heat from that particular spot and to try to heat up the rest of the board. And you're going to have to use temperatures like 400, 500 degrees Celsius, maybe even higher than that if you have a reflow workstation that goes higher. And you kind of run the risk of maybe melting some parts because you're using higher temperature than normal. So this is going to take a minute for it to set up. In the meantime, while this is heating up, let's show underneath the microscope what we are working with. Try to get this in view for you guys. So there are all the pins, and they're very closely together. It doesn't look like any of the pins were damaged in the process on the back end of the HDMI port, so we don't have to worry about any trace repair. That would be those tiny, tiny little pieces of copper that you see going up to the pins right there. Sometimes those can get physically damaged and ripped off the board, and when that happens, you're going to need to have a higher skill of repair to where you can actually solder jumper wire in the place of where those traces were. We're very fortunate that that's not the case here. We can just start heating up the board and lifting up the HDMI port. So a couple of things we're going to need. Obviously, the board preheater. We use a rework station, specifically the brand Quick 86 1DW. It should be listed in the description below. And then a soldering iron. A couple of different soldering irons we use here. I have some tweezer irons, some a pencil soldering iron that has a knife tip on it, and just a large soldering iron itself. The brand I like to use is Hakko. The setup I have is Hakko FM203. All that is in the description below. And a multimeter too, if you'd like to check for continuity to make sure that your pins aren't accidentally bridging or touching one another. Solder, obviously, and flux. The flux we use is Amtech brand flux. And this one, I forget the exact variations of the Amtech flux. This should be listed in the description. Used to get all of my flux from rossmangroup.com. Not sure if they still sell it, but I stocked up on a good bit of it, so I'm good for now. But this stuff specifically, it's the Amtech NC559V2. Also a fume extractor. This stuff is toxic. We are heating all sorts of metals and chemicals. It's not really good to inhale. Doing a motherboard repair isn't worth potential lung disease or cancer in the future. So you want to make sure you have your rework station, or not rework station. You want to make sure you have your fume extractor. So let's go ahead and turn ours on. We're already at 190 degrees Celsius on our board preheater. So I think we're finally at a point to where we can begin doing the repair. So I'm going to go ahead and turn this up. Let's do 440 Celsius. Now, every rework station is going to be different, so when it comes to temperature and temperature values, you want to make sure you're familiar with your specific rework station. Some rework stations might put out a higher airflow, so you might not need as much heat as what I'm going to be using here. So when it comes to exact values, I really recommend just kind of seeing what works best for you when doing this particular repair. So if we go back to our microscope camera here, what we're going to need to do is go ahead and apply flux. Now I'm going to be standing up while doing this repair because I don't have a chair that's tall enough. And so I'm just putting flux on the pins itself as well as around the grounding points which hold the HDMI port in place. Also, we need to turn up the flow or suction rate of our rework station. So let's go ahead and turn that on max. Stay hydrated. Water's good for you. All right. And actually, to make sure I don't burn myself, I'm going to grab something to cushion or to act as a barrier for the heat. I've just got a nice rubber mat right here. And only because my hands are sensitive, I'm actually going to double layer my gloves. This is just going to prevent them from heating up too much, so I don't burn myself. Alright, so I'm going to put this mat on here, just so you can see what it is. It's just an area where I can rest my hand when I start pulling up on the HDMI port. And let's go ahead and start working on removing this. So, rework station, got the rework gun out, and we're going to go around in smooth circular motions because we want to heat up the entire HDMI section. Not just one part at a time, because then the heat's not even. So when we pull up, one side of the solder may be melted, but the other side is still going to be solid or not melted yet. Forget what the technical term is. So we're going to go ahead and just keep going around. This is probably going to take about a minute, can take up to about 2 minutes or so. And you should be able to see the pins will begin to melt. They're going to get shiny. Right now they look a little rigid or dull because they're not hot enough yet. So when they get to the point they start looking shiny, then we can actually lift up on the HDMI port. Now, you don't want to just start pulling up on the port without the pins being melted. That's how you end up with damaged traces. You want to make sure the entire port is nice and heated up before you actually pull up on it. Damaged traces will end up extending the turnaround time on this repair, and you really just don't want to prolong this being under the heat gun or on the board heater for too long. So I'm just grabbing a leg right now, very gently pulling up just to see if I get any wiggle room. Any wiggle at all from the HDMI. And it's still pretty solid right now, so let's keep going. Gotta focus more on the sides, on the legs. I also have the microscope angled a little bit, just so I can see the pins better at this angle. And by now I would imagine I would have had some sort of movement. I'm not getting any of that just yet, so I am going to increase the temperature of my rework station. And to continue, just go around in a circle. It looks like those pins are beginning to get shiny, so those are beginning to melt. What's not melting yet is the actual standoffs, where the HDMI is going through the board. That's what's actually supporting the HDMI. That's connected to ground, and as I mentioned earlier, ground is going to dissipate heat just as quickly as you're heating it up. Or I shouldn't say just as quickly, but it is absorbing some of the heat. And so the ground always takes the longest to heat up. Things are starting to look a little dry here, so while I'm heating it up, let's go ahead and give it a little bit more flux. Don't worry, we're going to end up cleaning this later. Don't be afraid to use too much flux. Alright, let's see if we can start pulling up on the port. What makes the Xbox HDMI a little harder than like a PlayStation HDMI is on the front part up here. There is a little bit more solder that's holding the front of the HDMI port to ground, just for more structural rigidity. And I'm starting to lift up on the front part. I'm starting to get more wiggle. So this is starting to lift up. I'm not pulling too hard. I'm just kind of gently wiggling it, kind of like a loose tooth. And you can see all of the pins down there are beginning to move too. There we are. Perfect. And it looks like there is a dab of glue, almost like a black resin, that was holding the port in place. So there's the old HDMI port. Let's go ahead and set that to the side. Put that in front of the fume extractor just because it smells. We need to clean this up and get it prepped and ready for our new HDMI port. So one of the things I'll do at this point while the HDMI port is out is you can see the standoffs, those 4 standoff holes. We're going to try to wick up, suck out some of the solder that's in there. So I'm going to use some Goot wick. The type I like is Goot wick CP1515. And we're just going to cut a piece off. Let's go ahead and cut a couple of pieces off. All right. Apply a little bit more flux in there. There actually is a little trick you can do too. You can get a soldering iron and some of our leaded solder, since leaded solder melts at a lower temperature. Let's go ahead and put some in there. This is going to help us wick it up faster. It seems counterintuitive that I'm putting more solder in the hole, but this is going to allow the wick to really grab that solder and kind of pull it. Now, let's go ahead and get our wick, put it with a tweezer, and then try, if my hand stops shaking, to wick it up. You can see it's just really starting to suck the solder right out of that hole, out of the through hole, the standoff hole, whatever you want to call it. Sometimes I can't get it out all the way. I just want to get a good bit out so we can get new solder in there. And see this, it's a lot of solder that's in there, so this wick is pretty much done. It's completely silver, it's already soldered or filled with solder. So let's grab another wick here. Another trick we can do, if you're advantageous enough, is that you can grab your rework station while holding it with a soldering iron, and this is just going to heat up this area a little bit more to really pull that solder through. This isn't a required step to use the rework station, but it pretty much pulled that entirely out. You can see now we actually have a hole through there. So that's just another trick you can do if the solder is fighting you. Let's get a little bit more wick for the right side now. Now that I have my wick ready, put it on a tweezer, try to grab that, and it's just starting to come right out of that hole, right out of the through hole, the standoff hole. In the process, you can see this tiny little component down there. Avoid that. Do not touch that. It is required for the HDMI to work. You do not want to knock that off while you're wicking. If you're a repair shop, I recommend keeping those in stock. Sometimes an HDMI port can get damaged so bad that that gets knocked off in the process, just from the initial damage. I'm going to do what I did earlier. I'm going to use the rework station. And we're good. All right. Go ahead and get rid of that wick. There's still another part that we have to wick. You can't really see it under the camera, but you can see up there at the top. You can kind of see right up here. There's some more solder, and really what I want to do is just kind of touch that up with some of our leaded solder, just so that when we put the replacement HDMI port in, that's really going to grab the front part of the HDMI port and give it some extra support. Let's see if this piece of resin, yep, that's going to come right off. So Xbox or Microsoft takes it a step further when it comes to securing the HDMI port. It looks like they use a little dab of epoxy, resin, glue, something else to hold the HDMI port in. Now, before we go ahead and get the replacement HDMI port in, we really want to clean up that area. The problem with flux is when you start to heat it up too much, flux starts to get this very like tacky texture, and it's difficult to clean. So let's go ahead and clean it up before we start putting some new flux on there. For that, I like to use a combination of acetone and 99% alcohol, isopropyl alcohol. So let's start off with the acetone mixture first. This is just normal. This is 100% pure acetone. You can get this in the cosmetic section of your local beauty salon, or not salon, but beauty supply store. Walmart has it right next to the nail polish, because this is technically a nail polish remover. I found that flux is more soluble, or seems to be more soluble, with acetone. At least the really thick, chunky pieces that have heated up and gotten to that tacky point I was talking about. And then isopropyl alcohol takes care of the rest. And put some of that on a Q-tip. Kind of clean that area up. Yeah, that looks a lot better. So at this point, our HDMI area is prepped and ready to have a replacement port installed. We are now at a point to where we have to make a decision. Do our pins look like they need to have new solder applied to them, or can we just put flux and use the existing solder? Try to get this back in focus. And so to me, all but one pin look like we can reuse the solder there. For the sake of this video, I'm going to wick up all of the pins that are on there and just apply a new layer of our leaded solder. This is going to help the new pins on the HDMI port just kind of suck to the board, or use surface tension and kind of pull itself back onto the board. Some repair shops will end up just reusing the solder. It's not the worst thing to do, but for the sake of educational reasons, we're going to go ahead and replace the solder and kind of show how it is done. So, like we did with the through holes, we're going to put some flux on there. I already have some goot wick that is already cut. Remember, avoid that green component in the bottom. You do not want to knock that off. That will just make this repair significantly more difficult for you. There we go. Nice and clean. So, Just for extra measure, let's put a little bit more flux on our pads here. And let's just run a bead of solder in there. And I'm just kind of going back and forth. Everything looks nice and leveled. Let's clean it up like we did earlier. Those solder mounds look a lot shinier than the ones that were there earlier. So we are now at a point to where we can replace the HDMI port. So this is an HDMI port that we ended up just getting from Mobile Centrics. This one specifically is for the Xbox Series X. There are 4 different Xbox, well, 2 different Xbox series. There are 2 different Xbox Ones. These are the 4 most common Xboxes that you would repair. Doubt anyone's really bringing in like an Xbox 360 anymore. But this is the Series X. The Series S is not compatible. So you need to make sure you get the correct HDMI port. I'm just going to do a visual inspection to make sure that the pins themselves don't look crooked or bent in any way, and they look great. So we are good to move forward with this repair. So I'm going to move back to the microscope camera. And we're going to apply some flux. Let's actually put a little bit of flux in the standoff holes, as well as some flux up here and these, I don't know, mounting pads. I'm sure there's a technical name for it. Alright, and let's try lining this up. I'm just going to do it by hand, and see, that just went in flawlessly because the bottom of the HDMI port actually has 2 plastic pegs. Now, again, we have a decision that we can make here. I've already made up mine. But we can either go ahead and start reflowing the HDMI pins with our rework station so that they kind of suck or use surface tension to pull the pins onto the motherboard, or we can go ahead and put some solder on our standoff mounts. I'm going to do kind of a mix of both. I'm going to put a little bit of solder in the right side mounting standoff pad or through hole, just to kind of really hold the HDMI port in while I reflow the rest of the pins. So for that, we just need our large iron. I'm going to touch the side of the HDMI port and just run a little bead of solder in. And while I did that, the whole HDMI port itself kind of shifted a little bit. So let's make sure that all looks still fine. So for good measure, let's go ahead and put a little bit of solder on the left side. So that's really just going to act as like a thumbtack that's going to hold our HDMI port in place while we reflow it. So now, let's go ahead and put even more flux. Don't worry, we're going to take care of those front standoff pads, standoff through holes in a moment. But let's focus on actually reflowing those pins back onto the motherboard. So like we did earlier, we're going to go around in a circle. It'll take about maybe a minute or two before we start to see those pads underneath there solder and kind of grab those pins in place. So I can see some of the pads are beginning to melt. All right. You can kind of see they're all looking a little shiny. One of them actually just kind of moved and pulled the pad in place. It actually looks like for the most part they all grabbed and pulled themselves in. So we are good there. Some of the pads look like they could benefit from a little bit more solder. And so for that, how you would approach that is to use a fine tip soldering iron. This is where the pencil or the tweezers come in handy. They're on there. All the pads look great, and we can also do a wiggle test, which is when you take a tweezer or a scalpel or some sort of sharp tool and just poke each pin and see if any of them wiggle. But you can see kind of on the right side there, those pads, they look naked, they look bare. I want to have a little bit more flux on there just for sheer rigidity reasons so that this doesn't come back for a warranty or an RMA. The majority of the time spent on this repair is disassembling it, so I'd much rather just go ahead and make sure that the job is done right so I don't have to redo it, and also just save the customer some time too. Makes everyone happy if you just go ahead and spend a little bit more time doing the touch-ups now than having to redo the entire repair all over again. My heat mat is actually at an uncomfortable temperature now, so I'm going to replace it with another one that I have. One moment. This one's just a giant piece of silicone. Back to the microscope. So this iron is much smaller. It is much smaller than my larger tweezer, or my larger iron. It looks like there we go. We just needed to properly turn it on. So kind of like an ink and quill method, I'm just putting a dab of solder on the tip. Ooh, that silicone mat's not doing anything. Putting a dab of solder on the tip of the soldering iron and just kind of brushing it over the pad and letting surface tension do the rest of the job. Hands are shaking more than normal today. I haven't had lunch yet. Awesome. I believe we are good. Now, to test that, like I mentioned earlier, you can use a tweezer and do what someone has told me they call it the wiggle test, and that's where you poke. I need tweezers that aren't broken. You poke every pin and see if it moves or wiggles at all. And if there's any movement, then the pin is not soldered onto the motherboard. And perfect, we are golden. So, now we're at a point where we need to finish soldering the rest of our pads in the front of the standoff through holes. So, let's go ahead and put some solder on the front. And get our large soldering iron. Go ahead and put some down there. This is in a hard to reach spot. But we got it. So put a little bit more down here. And then this one's a little difficult to see without shifting the entire microscope over. And that should be it. Let's see if we can see if the through holes actually soldered all the way through. I'm going to change the camera. And we're actually at a point to where we can turn off the preheater. We don't need it anymore. This is very hot, so I'm going to get a microfiber cloth and pick it up. And so, I'm glad we did that because the through holes, there's not enough solder in there. The rework station is turned off, not the rework station, the preheater station is turned off. So this is starting to cool down. We're going to go ahead and just put some solder right there. So I just flipped the board over. Let's see if I can get this in view. Come on. Okay, for the sake of the video, I'm going to prop this up in a weird way. So let's go ahead and put some flux, and we're going to heat this up from the underside. The board is still hot enough to where this should pull the solder to the other side of the board. And I'm just going to put a big glob, and I can see that it's actually pulling itself through. Let's do the same thing to the other 3 standoffs. And so I'm watching the mound that I'm making here get smaller because it's actually pulling itself through to the other side and attaching to the side of the standoff. So even though I'm adding a huge bead, it's just sucking itself or pulling itself through. And that's really what we want. We don't just want bare mounds because then we are not entirely sure if it is touching the legs of the HDMI. So in theory, since it keeps pulling itself through, when I lift this up, we should actually see some solder on the sides, and I do see that. I actually see a great bit, so it definitely is mounted. Just so I can show you. And I'm going to clean that, the flux that's there. So if it'll focus, you can see the mound on the sides because it pulled itself through. This one's a little harder to see. Keeps on trying to, there we go. So you can see right there, it pulled itself through. So that is the solder from the back end going all the way through the through hole and really grabbing the leg of the HDMI port. So we are at a point to where the last touch up I want to do is, it looks like we have a lot that came through on that side. I'm just going to touch that up while holding this. And I'm not even going to worry about a wick right now. I'm just going to use the soldering iron to kind of act as a wick. It's actually grabbing the entire sidewall. This pulled a lot through, but those mounds aren't large anymore. The nice thing about this soldering iron, it actually has like a hole in it, so it doubles as a wick and it pulls through. It pulls wick into the soldering iron. So we should be good here. We can go ahead and turn off the rework station. And let's give this a nice cleaning. This is, it's still hot, but it's cooler. Don't leave a microfiber cloth on a board heater when it's on. So just like before, I'm going to take some acetone and alcohol and a Q-tip, really get in there, clean this up. I've seen some people use a electric toothbrush for getting in there and scrubbing. Nothing wrong with that method too. You can do that if you'd like. And it looks like we just kind of lost part of this thermal pad. It's no longer attached, so we're just going to throw that away. Same thing, let's flip this over here. Now there are a couple other things that we need to do for this repair. We need to test it out. We also need to replace the thermal paste, just to give a nice solid connection of thermal paste to the CPU and the heatsink. It also looks like it's just never been replaced before, so it could benefit from it. It'll run at a cooler temperature when playing Rocket League or Fortnite or Call of Duty or whatever it is you like playing. So this is the part, I'm going to end up cutting this part out of the live stream because we're going to reassemble it to make sure, we're going to halfway reassemble it to make sure that it works. I'm going to end up making, or attempting to make a video where we just clap our hands and then show that it's working. Alright, so let's begin to put this together. Oh, and actually for the social media, I forgot. Alrighty. That should be everything that I need for now. I hope that this repair is interesting and worth doing educational videos on. The board repairs, the MacBook board repairs, I really haven't had as much free time to dedicate for doing videos on. So we'll see how this turns out. I'm really starting to shift gears to where this YouTube channel is going to be more educational on easier repairs or common repairs than we have done with like MacBook logic board repairs. Something that's a little bit more obtainable. For the sake of quality control testing, we are actually not going to worry about replacing the thermal paste just yet. I just want to make sure the HDMI turns on. Proof is in the pudding that this at least boots up. So I will go back and we will fix that or replace that. But yes, so as I was saying though, I'm wanting to make videos that are probably more repair friendly from a entry level to intermediate level of board repair rather than an advanced level of board repair. Honestly, even just repair in general. Something a little bit more educational, something that you could probably find on iFixit. The logic board repairs were just getting to a point that they were getting more time consuming. I still do them. I actually have 3 more that I have to do today. Missing this bracket. Sweet. Is that what this one's held down with? Yes, you're right. I'm assuming the big ones?
Those are for that.
For which one? The heatsink?
Yeah, these 4 for the heatsink. I think these 4 go onto the logic board?
Okay. Yeah, that looks right. Let me grab a screwdriver. Oh, hey, chat is starting to blow up. Hello. What type of repairs do you do? We are an Apple repair shop. We specialize in Apple repair. iPhones, MacBooks, iPods, iPads. We don't do the Apple Watches anymore. They're just not economical. And we can't waterproof them. But we also do the occasional video game console. Xboxes, PlayStations. We don't do Nintendo Switches anymore. Nintendo is getting to a point to where they are just not repair friendly. Jerry, do you recall the orientation of this X bracket? Was it like this or was it like that? I'm assuming it's the other way because it looks like it'd be laying on some transistors. Yeah, right. That looks right. Okay. Thank you. But yeah, Apple product repair, we're kind of an alternative to the Apple Store. We do a lot of liquid damage diagnostics, liquid damage repairs, some data recovery. And then for our local customers, we do a lot of consultations. Basically, everything that you would expect from the Genius bar, we try to fill in the gap. Oh, gosh, I'm sorry. I didn't realize chat blew up as much. Hello. Hello to everyone. Thank you so much. Let's see. B7000 glue won't make it waterproof. It will not. B7000 is a good adhesive, but it will not waterproof. That is exactly what we were using. We even used to use the OEM water seals that came from Apple. Apple uses a very specific machine for sealing the water seals on an Apple Watch. Also, you can get a new Apple Watch SE starting at $280 in the US, so it doesn't really make sense to do a repair that you're probably going to charge a customer $200 to $250 to repair when they could just go buy one for $50 to $30 more. So for those, we're spending more time than it was worth, and it wasn't profitable. So we quit doing Apple Watch repair for that reason. Apple has something called an out-of-warranty exchange, to where you can just go to the Apple Store and give your Apple Watch for store credit towards the cost of a replacement one. I bet you find shorted components all the time. Yes, it can. Typically from liquid damage. Liquid damage will cause a lot of shorted components. Shorted components are the easiest of the board repairs because you can typically trace them down using a thermal imager, an infrared camera. I would say we get shorted devices 40% of the time. The other 60% is just all sorts of random issues like firmware issues. Okay. What else do we need for this to turn on? I need this guy. Is the controller without needing the front option?
Do you need the screws for that?
Shouldn't. Let's find out. All right. I'm going to see if we can turn on the Xbox without needing to put it in the frame. And then I need a power cable and an HDMI cable. This was the part of the stream that I was not prepared for, so I'm just moving things around right now. This channel, though, is strictly educational. We do not make money, or at least we don't make a lot of money from YouTube. That is not our form of business. Like Louis Rossman said, I'm just a guy that films my job. All right, we need our power cable. Let's see. Hello to everyone that has joined. Thermal cameras, do you have one? Yes, we have a Keon Lee, I don't know the model number. Thermal imagers are expensive. This one we bought back in 2019 for $800. We've gotten our money's worth, but I don't recommend getting it unless you are a repair shop that is doing board repairs. If you're just someone that's just trying to fix a one-off repair, it may not be economical for you. Okay, power cable, HDMI. Can we turn this on with just the controller and everything else removed? HDMI cable, power supply. Is the power supply connected? That's pretty important, right? Power supply is in fact connected. We might need to actually put this one more together in the frame. Was there any other daughter board over there? I think these are just dang, that's expensive. Yes, it. If we're referring to Apple Watch repair, yes, Apple Watch repair is very expensive, and it just doesn't make sense. Economically, it no longer makes sense. Okay, so it looks like we do need to have some part of this Xbox connected into the power button area. Let's see if we can cheat. Like I said, this is strictly educational at this point, just proof to make sure that it turns on. Power button is connected. I heard a chime. And let's see if this turns on. If this turns on, I'll end up moving the camera just to prove that it's on. Excellent. And it's on. Let's see. Perfect. Is in a very Frankenstein position right now. So there's the Xbox. I don't have it in the housing because we don't have all the screws attached, but we have an Xbox logo. So the last thing I recommend doing at this point is a wiggle test, just simply wiggling the HDMI port and see if the, ooh, don't want to put customer information out. Let's go ahead and put that back. And yes, the HDMI port repair was successful. So now we are going to go ahead and finish the rest of the repair with the thermal paste for cooling performances and put all the screws, put it back in the housing, and then call this customer. But it passes the wiggle test, it passes the HDMI test, so that is a full successful HDMI repair. So with that being said, I think that's the end of this video. I'm going to end up cutting this out a little bit more and try to condense it down into just a tutorial video instead of a full-blown live stream. So with that being said, I do appreciate you guys joining. If you have any comments, questions, or concerns, definitely let me know. If this is content that you liked, then definitely let me know, and we'll probably start doing this form of content rather than MacBook board repair. And if this is a repair that's something you just want to send to us, we do mail-in repairs as well. You can go to iRevive.com. We have a little tab at the very top that says mail in. Just fill out your contact information. We'll get it in our repair system, and then you can just send it to us. And you guys are sending a lot of questions. We don't get to see the thermal camera, not in this repair. There's no point of using the thermal camera because nothing was shorted. So with that being said, I'll see you guys in the next one. Thank you so much for joining. Have a wonderful afternoon.